Hi, today we are looking at section 4.2, which is reflecting graphs of functions. So we'll be looking at two main types of reflections, one that's over our x-axis and one that's over our y-axis. So reflecting in the axes for our original function y equals f of x, y equals negative f of x is an image of our graph of y equals f of x after a reflection in the x-axis. So this is often referred to as a vertical reflection because our graph is reflected vertically. Now, any point on our graph of y equals f of x essentially has its y value change to the opposite sign. So if I had a y value of 4, it'd become -4. If I had a y value of -5, it'd become +5. So if we have this graph here, which is y equals f of x, if we then graphed y is equal to negative f of x, that's our reflection over x-axis. So that makes all of our y values change their sign. So if we had a vertex at 4, 1, our new vertex would be at 4, -1. And like I said, it would be reflected over the x-axis. So essentially every y value changes its sign. So if we have a negative in front of our function, it is a reflection over our x-axis. Now, if we have the negative inside our function, it's instead going to reflect it over our y-axis, which is referred to as a horizontal reflection. Now, for our horizontal reflection, our y values are going to stay the same, but our x values are going to change to the opposite sign. So let's just draw out a couple of examples. Okay, so let's say that we still have y equals f of x having a vertex at 4, 1. If we have the graph of y is equal to negative f of x, the y value stays the same, but the x changes sign. So we'd be over here at -4, 1. So as you can see, it's being reflected over our y-axis. Okay, so we'll look at an example. Given the graph of y equals g of x, sketch it after reflection in the x-axis, as well as reflected in the y-axis. We'll also give domain and range for all three graphs. So here's our graph of y equals g of x. So first one I'll do is reflect it over the x-axis. So if we had -3, 1, that become -3, -1. -1, -2 becomes -1, +2. 3, -2 becomes 3, +2. And then this last one, we had 4, 2.5, so it becomes 4, -2.5. So this is what our reflection in the x-axis did. So if as in the x-axis, we can also write that as y is equal to negative g of x. Next, we'll do over the y-axis. So if we had -3, 1, that becomes +3, 1. If we had -1, -2, that becomes +1, -2. We had 3, -2, that becomes -3, -2. And if we had 4 comma 2.5 becomes -4 comma 2.5. So join those points. And we'll write out an equation first. So this would be y is equal to g of -x. So next we'll look at the domain and range of all three graphs. So I'll just color code it. So black will be our original graph. So our original graph, we had an x value of -3 and we had to +4. So we have x is between -3 and +4, where our range for that same graph, we went from -2 to +2.5. Next, we'll look at our function reflected over the x-axis. So for it, we can see we went from -3 to +4. So you can see that when we reflected it over our x-axis, our domain did not change because that's the exact same as our domain here. Next, we'll look at our range. So our range looks like our lowest point was -2.5 and our highest is 2. So you'll see our range did change. Essentially, whatever was here ended up being multiplied by -1 and ends up here. Whatever is here was multiplied by -1 and ended up here. Okay, looking at our one reflected horizontally now, so over our y-axis. So our domain looks like we went from -4 to +3. Now you'll see that is the same as our original, except for we've multiplied each of these by -1 and changed their locations. Our range, when we look at this, we go from -2 to +2.5. So if we reflect over a y-axis, our range stays the same. Next example, given the graph of h of x, graph -h of x, and state domain and range. So key thing here is we can see that the minus is outside our function. So that's reflecting it over x-axis, which means only our y values are going to be changed. So this y-intercept of 1 becomes -1. If we're at 1 comma 3, we end up at 1 comma -3. 2 comma 1 becomes 2 -1. 3 comma 2 becomes 3 -2. So we can see this one will look something like this. Now for this, because our graph continues further this way and further this way, our domain is all real numbers. Our range, we started at -3, continued all the way upward, so therefore y has to be equal or greater than -3. Okay, writing the equation of a reflected graph. For a reflection of y equals f of x in the x-axis, so our vertical one, we essentially multiply our original equation by -1. So if our original equation has multiple terms, each term gets multiplied by -1. Now for a reflection in the y-axis, so a horizontal one, we go through and find every x and replace it with -x. So we have a couple examples here. We have a graph of y equals 1 over negative 2x squared minus 0.5 plus 2 was reflected in the x-axis. What is our equation of our image? So what we'll do is go through and multiply every term by -1. So when I multiply this one by -1, I have the choice of putting the negative in the numerator, or because both of these were negative down here, I could multiply each of these by the -1. So that's what I'm going to do. So this becomes y is equal to 2x squared plus 0.5, and then multiply this 2 by -1, so -2. This one reflected in the y-axis, so that means we replace our x with -x. So we've got y is equal to the square root of negative x plus 2 minus 3. So we'd have y is equal to square root of x plus 2 minus 3.